In the previous part, we start learning support vector machines. In this lecture, we will continue it. First, let's practice by doing another example of adding a new feature. Here is the dataset that is clearly not linearly separable. You won't be able to find a line that separates the axis from the circles within the XY coordinate system. But now I'm going to ask you to add one more feature, and that feature should make it linearly separable. Here are few options or possibilities. Choose which one make it possible. X square plus y square, the absolute value of x, or the absolute value of y. The absolute value just takes out the minus sign. Google absolute value if you are not clear about it. Take one of those options. The answer is the absolute value of x, and I can prove it to you. If you were to show the absolute value of x, it can't be negative, as I said before. And all the points here get moved from the negative side to the positive side. So this point in particular over here become this point here, and this point over here becomes this point over here. So this is how it looks like if you look all the points to the absolute value of x coordinate system. You just flip them over, and if you look at this diagram, what you find is that there is now a beautiful, perfect, linear separation. And if you ask yourself, how did the linear separation look in the original space of x and y, is effectively something like that. So it is a non-linear because it has this inflection point over here. I hope you understand that the adding this new non-linear feature makes the support vector machine linear and separate the axis from the circles. This sounds very useful. But do accountants have to write a bunch of new features? The answer is no. This is clearly a different type of work than accountants usually do. It is useful but complex. And the cool thing about the support vector machine is that you don't have to. There is something called the kernel trick. I won't be able to explain it in full in this lecture, but I will just give you the gist of it. These are functions that take a low dimensional input space or feature space and map it to a very high dimensional space, so that what's used to be non-linearly separable turn this into a separable problem. And without going into any detail, these functions are called kernels. So I encourage you to check further details about it on Google or scikit-learn. These aren't just functions with a feature space. These are functions over two inputs. When you apply the kernel trick to change your input space from XY to a much larger input space, separate the data point using support vector machine, and then take the solution and go back to the original space. You have now a non-linear separation. You can take a very simple idea of finding the best linear separator or linear line between the different classes. Apply what's called the kernel trick in a higher dimensional space, and what you effectively get is a very, very powerful system to set dataset apart where the division line might be non-linear. This is amazing and one of the most central trick in all of machine learning. Now let's see in sklearn documentation how kernels are supported in the actual code. I noticed that there are different kernel functions that can be specified for the decision function. There are common kernels that you can use straight out of the box, and there is also the option for custom kernels if you want to get really fancy. We will be just using the common kernels that you can just use out of the box, but you can also write your own kernels. The second thing you would notice that there are several different SVMs within scikit-learn that you could use, for example, to deal with the classification type problems or regression, or for detecting outliers. The one that we are using here is SVC, the support vector classifier. And that takes me to another documentation page of the support vector classifier. And I have this box at the top. This might be a little bit reminding you of what we were seeing in the naive based documentation earlier. We have this whole complicated thing here that tells me how I can create my SVC. And I notice that there is all sort of arguments or parameters that I can pass when I'm creating it. One of these happens to be the kernel. Now let me take you back to the code that I wrote for the pictures I shown you earlier for the same dataset. This line right here where I'm creating the classifier, this line of code would work if these parentheses were just empty inside. What I have done is I have specified a kernel. So the first example where we had the straight line decision boundary was created using a linear kernel. And let's change it to RBF kernel to see how it would change the decision boundary, and here it is. In the next lecture we will see how auditors can use SVM to detect outliers in the population they are testing.